Welcome and thank you for joining us for this technical session. If you'd like to track your session attendance in the Cvent app, the check-in code for this session is displayed here on the table. Please note that this code will only work for 15 minutes before the session starts until the session ends. Further directions on tracking course attendance are available in the Cvent app under the IHEEP 2023 event or in your printed program. This session is scheduled from 2:30 p.m. until 3 p.m. Your speaker for this session is Carlos Femmer. And then here's your bio for a second. Carlos holds the position of Director of Data Acquisition at HDR, overseeing the company's data acquisition and unmanned aircraft systems, UAS, initiatives across various market sectors. Before his role at HDR, Carlos had several leadership positions at John Chance Land Surveys Incorporated, including Vice President, COO, and President. There he managed numerous aspects of the company's growth, innovation, and strategic direction, particularly within the land survey and airborne units. Thank you.
So we're going to go ahead and jump in. Make it 25 minutes. We'll have about 5 minutes for questions and answers. But there's a light, with folks in here too. If you have any questions, since there's not as many, feel free to ask a question, in between too, and we can do that as well. Yeah, so today we're going to be talking about IoT or connected sensors and digital twins, and kind of talking a little bit about, I appreciate the introduction as well, talking about the data acquisition. Within HDR, we acquire data, we manage data, and we advise clients with the data that we capture. We work across the various life cycles of assets from planning, building, managing, decommissioning, and we leverage technology to find cost-effective solutions with big data, AI, and IoT. And the intent is to build geointelligence around assets. So what we'll do is maybe talk about reality modeling overview. Today we thought we'd give like a case study that makes sense. So we have a project that was out there. There was a landslide. You want to stabilize it, and then what's the best way to do that? And one way to do that is to watch and listen and have ears on the ground. Another way to do that is you might want to have 24-hour data being sent back. So if anything were to happen, you could get notified real time. And that's kind of what we're going to talk about today. What we ended up doing is connecting the land piece to the sensor piece. And by having that combination, now we have a digital twin where we can see where those assets and sensors are located with respect to truly where it's at from a survey perspective. So the first concept we're going to talk about is reality modeling overview. And reality modeling is capturing existing conditions in 3D using one or more combination of devices. So it could be drones, cameras, laser scanners, even all of them at the same time. And you build all of that together to support different applications like mapping, survey, digital twins, design, construction, and inspection. Here's just kind of a video overlap where a drone was used to capture this area of interest. And because you have it tied to survey control, you're able to now develop some survey deliverables out of there. So you can create some DSMs, you could create some DTMs. You have LiDAR, you have photogrammetry. In this case, and we're going to say on the timekeeping, let's postpone that, right? So we don't need to do that right now. But so it's a good application because the quality of the data from drones and photogrammetry can get down to 1 to 2 centimeters horizontal and then 3 centimeter vertical, which is phenomenal whenever you look at it compared to, and you're taking millions of points. And that's like you're going out there and capturing it with a GPS unit as well. Here's kind of another concept where we have explaining it again, using all of the different sensors and then putting all of this together to capture this asset. So in the case right here on the right, we have this bridge pier, and then that bridge pier was turned into a digital twin. So now we have a physical replica of that, or a digital replica of that object. And before we get into like the San Clemente, this is another one that's pretty cool. The way we do that is we might fly a drone, and the left side is going to be what the drone sees, and then the right side is what the view from the ground as the pilot or the operator. So the pilot's going to come out there and say, okay, what am I trying to capture? Here's my ground, here's my top, and then here's my bounds. And it's going to go and do two things. It's going to fly around there and model that, and using artificial intelligence, it's going to put that in memory. Then it's going to go out and say, okay, how tight do you want your inspection? So you specify it, and it's going to go and produce that. So with that information, now you could come back and reconstitute that in various products like Pix4D or Bentley Context Capture to produce a digital twin. I always thought it's good to see, how the system works in the background, and that's kind of the view of it. On the digital twin front, here's the project in San Clemente, a digital replica of the built-to-natural world, basically a digital mirror of the physical asset, and it can be connected to sensors for real-time data input. In this case, we're looking at about 700 feet of an area in San Clemente, California that was positioned to stabilize a landslide that was happening. So in this particular case, with the landslide, it was impacting homes, and you have red tag, you have yellow tag. Red tag is, there's some issues with the home, you're not coming back into it. Yellow tag, it's, hey, there's caution here, you can't, it's not habitable. So by using data like this, we're going to see how that information can be used to impact the community and other benefits as well. So if we look at digital twin maturity, we have level 0 for reality capture. That's what we talked about initially, of just capturing the ground. We have level 1 where we have 2D maps and 3D models. We have level 2 that's connected to BIM, or 4D construction, staging, 5D cost estimating. Level 3 enriched real-time data, or IoT. Level 4 and level 5, this is kind of the continuum of like the digital life cycle. Today we're going to be talking about level 0 and level 3 together, where we're using drones to capture the information, using the sensors real time together, and producing this model. So case study we're going to look at is Orange County, California. In 2021, a landslide suspended passenger rail and red tagged and yellow tagged nearby homes, prompting temporary stabilization measures. In 2022, movement accelerated, necessitating a long-term stabilization project. So on the project detail front, 700-foot long site of a key rail route between San Diego and Los Angeles. Installation of large metal anchors to stabilize the slopes. That's what you can see over here, along here. And then HDR provided engineering support services for the project. So our role with producing this digital twin and sensors was we did a drone flight. We set out survey control points, so that way we have the digital twin on top. We have the sensors that went into the ground, and we'll look at where the positions of those were here shortly. We have a good relationship with various vendors. Phoenix is one of them, who's in the room too. And then we have Wingtra, they're based out of Switzerland. So we try to use the best of breed drone for the project. So we have relationships with 10 plus vendors, and depending on the project, we bring the best suite of tools for it. So in this case, we used a Wingtra fixed wing vertical takeoff and landing drone. That was able to capture the area of interest to get the survey quality we were looking for on the ground. We used a Bentley context capture software to combine the imagery with existing survey control to develop interactive 3D models for the project site. And then the sensor integration, we had two IoT sensors, or IoT-enabled inclinometers that transmit data to Bentley SenseMetrics platform. Another coolness factor, this is what it looks like when we talk about vertical takeoff and landing. That's the drone. It takes off vertically, which means we don't need a lot of footprint on the ground, and it'll turn into an aircraft. It'll fly the area, and then whenever it's done, it'll capture the area of interest, and it has an onboard post-processing kinematic, so it's not real-time like a GPS. It uses a PPK, or post-process kinematics survey data quality to produce it. So again, if you look at our footprint, we had a congested area in a road, and there's some other fixed-wing drones that you take and land, and it has to belly land. Well, you need a huge runway, not a runway, but you need a long linear swath, a corridor, and sometimes you don't have that. So what I like about this platform is we use the same platform in the Grand Canyon. We had to launch from a 15 by 15 helipad. There's nowhere else to do it just because of the terrain. And being able to launch it there, do the work, come back and land is the right tool. So we felt like this was the right tool for the job in this case as well. This is a look of the digital twin. We're going to see a little video of that as well. But again, we have all of the data on it. But before we move forward, wanted to just highlight two areas here. We have positioned two inclinometers, one on top of the bank where the landslide's happening, and one on the bottom by the rail to see what was impacted. So again, when you're looking at the position, what are you trying to accomplish with it? What we wanted to see is, okay, is it stabilized? So number one, is it still moving on the land? And number two, is it impacting the rail asset? So by having two of them working in concert, you're able to see those values and monitor those independently. This is a look of the inclinometer. It has a solar panel to keep it fed for power. And this one was drilled to about 55 feet. So one of the questions you have is, okay, there's a landslide. It doesn't matter where it's at. And that landslide is happening. We just know it's happening. So, but one of the benefits is, okay, where is it happening at? So what we're going to see shortly is by having that drilled down and having numerous sensors that are tied to it, we're able to tell where that impact and that anomaly is happening. And then this is the sensor integration here, looking at the application now. So we have the digital twin on the top. We have it's kind of like a GIS system in a way where you could interact with it and highlight and click on these assets. So if you clicked on the one on the top, which we did here, you can see each of the sensors have the reading that's happening as well. So I can see real-time data from my office. I'm based out of Lafayette, Louisiana. This project's in California, but I can look at it and see what's happening now on the project site. And then it also has alerts set up that it can automatically trigger based on what threshold you set. Say if it moves beyond this, it's going to automatically send out an alert. So it's pretty cool. Here's another case. You don't need a digital twin. You could have just the data. So if we take a look at this, here's kind of a look at the data where and how you would read this is on the left side, we talked about 50 feet below the ground. And you can see from the top, this is the interesting part because from 0, and I'll use my mouse because I'm in front of the microphone if I walk over. So this is 0 up here, and then this is down to 47 feet. And if we look at where there's a shear, we can see between 22 feet and 16 feet, roughly. You know, that's where it's happening. So that's the ability to see where the shear plane's happening. And then also what's the distance that it's moving. So you can kind of monitor what's the distance of, you know, where's it at and then how much is it moving as well. And then here's the kind of talking about that digital twin and now taking it to fruition where now you could interact with it, turn it in 3D. It's, you know, geospatially where it's supposed to be. Now I could click on this inclinometer on the top, expand it. I think this one had 9 or 10 strands. And you can click and see the data real time. Or I could click on any of the other ones as well, and it's going back to that graph. So I'm coming back out. Now I want to look at the one on the near the rail asset. You could click on that, get another set of data points specific to that asset or that inclinometer. And again, rotate it in 3D. You could overlay any property lines, any earthquake area. I mean, any specific layers you wanted to add additionally could be there. What I like about this one is this is the chart view, because on the chart view, we call it, you can slice and dice. So again, we're looking at the same data that we explained before, but as it's loading up, I can say, right here I said, let's look at 1 hour, let's look at all time, and it's going to slice and dice that real time. Or I could come back and look at, up here I can say 2 weeks, I can say 1 week, show me the last day. So by just clicking through, you can pick what you're wanting to see specific to that asset.
Carlos, what was shown up in the other one with the digital twin, is that the maximum for that day, or is that what that's measuring, the maximum delta, or?
No, yeah, well, what it's measuring, so this is kind of the same view here. So what it's measuring is, if I look at, let me bring my mouse back. So this is in October 2022, this is when it was set up and installed. Okay. And this is kind of the line that it shows right here if we look at it. And then as we turn it on, as months went on, you can see that, okay, now it's moved, less than 1/4 of an inch. Then it's moved 3/10 of an inch. Then it's moved an inch. So every month that goes on, you can see what's the impact of the move. Yes, sir.
Sorry to interrupt, but do I understand you just had one sensor for that whole, did you say 700-yard section?
No, so we had 2 sensors. We had
One in the rail and one in the...
Yeah, one on the rail on the bottom, and then one on top of the bank of where the movements were taking place.
Because I'm thinking of the UK where they had a similar slip on the rail on the coast.
Right.
And they had different bits of the slip, had different mobility.
Right.
Could that not be the case here?
It could, except what they have, so this was like a known historic landslide area, so they already had a understanding of where that anomaly was. But I think what happened, to your point, further upstream, there was another incident that if you don't have this type of data, it's hard to predict. So in this case, only one was needed for that particular project area, but for the whole length of the line, another tactic would need to be taken for that, because to your point, something could happen 2 miles, 5 miles up the rail as well. So that's kind of how you would read the data here. So the PM or the senior geoengineering geotechnical section lead mentioned the inclinometers were a key decision-making tool. They informed the project team of movements along the landslide shear plane before they manifested it at the ground surface. This early and real-time warning system mitigated risk to our client and the project team and enhanced site safety during construction. So that's kind of what you want to hear too, as far as if you're putting something in place, is it having an impact? And in this case, if I go back here just to show one other aspect that happened, this is one that was a few months ago, and you can see that it's moved from, it's pretty steady, it's stabilized about 1.5 inches, and then on this particular day, it went from 1.2 inches to 2.2 inches, so it moved a whole inch. Well, that triggered, we set an alert, and that triggered alarms, and then, but whenever you look at the data, what happened? Well, at the earth movement, there was some bulldozer moving dirt, and it shifted it, so where that strand was impacted was just at the surface level, so very quickly you're able to look at it, what was the impact, what was the issue, find out where it's at what surface level, and then say it's not a concern, hey guys, don't go near the inclinometer, right? So that type of information, but it could have been, but it worked because it triggered. It could have been something where something happened at subsurface and this movement occurred, and then now you take action as the owner or whatnot. So the big picture in asset management, so we talked about digital twin, we talked about a little bit about artificial intelligence, ML. We haven't talked about that yet. Today's topic won't be on it. We use that in various inspections that we perform. We do a lot of inspections where we use AI to detect cracks, and that's done physically, but then we also do that manually as well. I'm sorry, we do it manually, but we also do it as in parallel, just to kind of review the results, but it's still done physically. And then IoT, which we kind of just covered with the inclinometer a little bit. Here's an example. We're doing some work with UDOT, doing some bridge inspections across, and from a digital twin capability, using drones, using LiDAR, capturing it in a specific method, you're able to generate and reconstitute that as a digital twin and use it in various applications. So I thought this was cool because this is one of the bridges somewhere in Utah. Where? I don't know. But they sent that over. Here's a case of like the AI, and this is kind of what we do to kind of train it. We take thousands or hundreds of images, and then you tell it, okay, train it on how to find a crack. And then what it does is it'll come out there and delineate and highlight it. Now we're working on some things where it could also digitize in 3D where that X, Y, and Z of the crack and draw the vector. So that's another benefit. When we do inspections for a lot of projects, they want to quantify how long was the crack, et cetera. So by having a digital twin, taking the imagery, tying it to survey, running it through AI, producing that vector, now you could just calculate how long were these lengths. And that's similar to somebody manually digitizing it, calculating that as well. So just another benefit of artificial intelligence. And then lastly, that IoT integration where we have a key partnership with Bentley and looking at ground settlement, foundation anchor displacement, slope stability targets. This is a good example on the slope stability for the project use case we just talked about, but for dams, we're looking at weir flow sensors. That's an important that's an important IoT sensor that they want to see for flow, and a few other things. So by combining all of those to the asset and using the fit for purpose, like we talked about on the drone side, when we did San Clemente, we used the fixed wing drone. Other projects for the bridge piers, we're using a smaller Skydio drone. When we do these big projects like we're doing for Bonneville Power, we use like the Harris and the Regal and the Phoenix system for those. So it's using the right tool for the job. And I think this is our last slide, so this is good on timing. So what we're looking at value add is sensor data was used to inform contractor activities in real time. Pressure grouting drilling, that was the one where they were drilling operations, moving some things, set some alerts off. We found out it wasn't a big issue, but it made us pause and say what's happening, which is great. Sensor data contributed to early resumption of passenger rail service 3 to 4 weeks ahead of schedule after 60% of the anchor installation, which mitigated cost of interim bus service and loss of rail revenue service. Sensor data informed safety decisions for nearby residential development. And then community benefits helped to stabilize residential area and was used to take some yellow tag homes and make them habitable again. So what was interesting during the survey is, I just asked a question, this is red tag, yellow tag, what does that mean? And they said, well, this is, these homes are impacted, so they have to move out. So what they're able to do with the IoT, not only the benefits of the project, but also had a community benefit because they're saying, hey, this yellow tag is stabilized, we're good, you can move back in. So whenever you're able to have a project that has a benefit for the community and the homes too, I think is a tremendous win that we're proud to be part of. So with that, thank you, and if you have any questions. Yes?
Since you have an alert system and the railroad goes by, is the railroad also alerted if anything happens?
They are, yes. Matter of fact, we don't want any ownership of it. So they have the alert. We just monitor it ourselves too, so we can be apprised of it and help. But I mean, from a legal and risk, great question. We want that, the owner has responsibility for it. We'll monitor it on their behalf. But at the end of the day, they own that and they get the alert. But if we get it first, we're all getting it at the same time.
And then was there a service level agreement for 9999 uptime on this, or?
Bentley has a service level agreement with that, correct. That's another thing. We don't want to develop this and manage it either. It's they have firms that have this service level agreement. That's what they're in business to do, and whatnot. So I know we have a solid IT department and stuff, but that's something we don't want to do. We put on the vendors as well. So it's providing the suite of hardware, but also the suite of software that's best fit for us. Yes, yes, sir.
So, I've noticed you're monitoring situations that are either catastrophic, potentially catastrophic. What about a common bridge? Is there any use for it?
I think so. So like when we're looking at like the bridges, what I've heard that they've done is they've taken this inclinometer that's vertical and they've laid it horizontal. So what you're able to do now on a bridge, and it's kind of like in the corner here where the carpet meets the baseboard, you lay it horizontal, and then you could kind of see if there's something you wanted to monitor, you can see where the displacement's happening, or if you wanted to track it. It's a tremendous tool because all along that 50 foot, it's showing where at along the 50 foot that we're seeing these angle displacements or whatnot. So I think that plus a whole host of other sensors would have tremendous benefit for bridges, we believe. Yes, sir.
Well, to add to that, there's inexpensive strain gauges that you can put on a bridge that would broadcast, an alert, or basically they're designed that they'll be quiet unless there's something happening, and then, over vibration or yield or anything that would go up. The problem is people need to be putting those on bridges, and then you gotta collect the data, manage the data.
Yeah, and just on another side, I guess it's about a month or two ago, I was reading somewhere where they're able to take like a video, because we're able to take video for like, we do a lot of dams and water within HDR as well. You could take a drone, just collect 60 seconds on a video from the top, and then you could calculate within 95% the current at the surface. It's not like an ADCP that's going to the bottom. But what somebody was doing some testing of, okay, well, real quick on a drone, on a bridge, let me come out there, just take a minute of video just from the side. So the cost to do that, you're not getting people on the bridge, you're not, putting people in harm's way, traffic control, capturing on the side, monitoring it, and then doing some similar displacement scenarios there too. So that's something of interest. It doesn't have to be a physical gauge. It might be a drone captured data set as well. Yes, sir. Yeah, I think it's wide open. I think some companies do that for sure. I think, like in this case with Bentley, this was the first or second project that, people talk about, okay, a digital twin, until you have it, it has to be connected to sensors. But the reality is, until about 3 months ago, no firm really had that connected. So you hear this definition of it that nobody really can do. And then now we're seeing it, connect the sensor with the data set. But to answer your question, getting creative with these sensors, you're talking about the uplink of data. Make sure you're in an area that you have good communications, whether it's hardwired or cell. Yeah, that's another thing. If you're dependent on a cell access in an area that's mission critical, and you lose that cell access, then you have your backup plan. But I think we're only at the forefront of like IoT and where it's going. So really excited about the future for sure. Yes, sir.
Not to pour cold water on bridge IoT, but the big signature bridges of the world, like in Japan, they IoT'd them 10, 15 years ago.
Right.
They've got control rooms and they're monitoring.
Yep.
They've had 15 years of data come in and
Right.
nobody's done anything. I
Yep.
guess bridge engineers, we have 3 bridge failures a year.
Right.
If they do their job right. So some people do look at ask the question about the cost benefit of
Right.
the stuff. And it's not to mean that the critical infrastructure doesn't make a lot of sense.
Right.
Putting them everywhere make less sense.
No, 100% agree. I think some of the, like you said, some of the bridges have a lot of this in place, but you hit the point. What's the cost of you know, where's that threshold and what's the value for it. So, yeah, but as prices come down, I think that's going to become more mainstream versus like 15 years ago. Yes, sir.
There's a question about quantities of sensors, and you sort of pair, like, high and low there, at 700 feet lengthwise. Is there a distance where you say we need a second pair? I mean, 700 feet seems pretty long for that one pair. You get to 1,000 feet, you get to 1,500 feet. What kind of, you know, findings, best practices you started to establish there?
Yeah, I think on this one, we're partnering with some of the vendors. Like in this case, that earthquake zone was well established, and that's why I was saying, like, it was within that 700 foot, and that's why only one was placed on the landslide and elsewhere, because it was on a historic landslide. If we were trying to monitor something a little bit more downstream, I think from a geological perspective, we have a geotechnical engineer. He's not here. He could answer that, but you know, seeing that it, yeah. Yeah, no, I think what was cool about this is it didn't require it, but there was a science to it of why that was done. And I think, again, because it was a known hazard, but I like your idea. Someone was saying that they felt like it was stabilized, and like 3 months later, 2 months later, another section had failed where it's never been done before. So, you know, where do you place that? That's kind of this geological, geotechnical realm, and not sure of the best practice, to answer your question. Yes, sir.
The best definition I've heard of digital twin here so far is if you're able to simulate and optimize your real asset, then you can consider it a digital twin. So I don't know if that fits here or if that's different than anything else you say, but that's easy to visualize and understand. So I was going to throw it out.
Yep, I love it. We try to keep it simple. It's a mirror. So if you go look in the mirror and and you can have a digital replica somewhere, you know, that's a level 0. Then you just build on it. So different clients, our answer is whatever the clients want to call it, that's what we're giving them. So, well, thank y'all. Appreciate it. Thank y'all. How many more you have today?
I have 2 more.
2 more. Oh, thank you. Oh, appreciate it. Are you going to Berlin?
That's awesome. Prep for Berlin. I took some great photos of him and I'll tag you on LinkedIn if that's okay with
Yeah, sweet.
you. Fantastic.
Cool, appreciate it.
Safe travels.
All right, thank you.